Hi Cheryl, this is Marcelo. Let's just review 3 exercises I didn't do during the class because I was thinking they were more than they actually were. Okay, they are actually pretty simple. They are all solved now. Okay, let's just go through them. I didn't know that when I just saw this Rx equals 1, I had no idea. And later, when we did some other exercises, I now understand them. So we have this point. We're going to rotate this point around the line x equals 1. X equals 1, it is this vertical line here. Okay, this is x equals 1. Let's make in green, it is this one. Okay, it is this line in here. This is x equals 1 because every point on this line it will have the x coordinate 1. Okay, so this x equals 1. Our point it is minus 2, 7 in here, so it is this point in here. Now we have this point. What is the distance from this point to x equals 1? Well, the coordinates, x coordinate, it is minus 2. Minus 2, this is minus 2, okay? Minus 2. If this is minus 2 and this is x1, from here to here we have 3 units. So if you rotate this around the green line, it is going to end up here, right? And this is going to be 3 units after x equals 1, meaning x is going to be 4, right? 1 plus 3, 4. And what about the y coordinates? The y coordinate is going to be the same. Why? Because we're just flipping over a vertical line. We're not changing the y. That is why x is going to be 4, because it is 3 units after this vertical line, and the y component is going to be the same. Okay, so this for this exercise. As for this other one in here, let's just remove the zoom a little bit. Okay, we have a point P. It is this one, this point in here. We have these points, and we're going to find its image, assuming we are making a rotation of 180 degrees. Well, 180 degrees, it is just like this. Okay, imagine this line connecting to the center round 180 degrees. It is 180, it is half of 360. Okay, it is just make symmetrical on the third quadrant in here. There is nothing more to say. It's just going to be symmetrical. If this is 0.3, so let me just increase here the zoom. Okay, if this is 0.3, this is going to be minus 3. If this is 0.2, this is going to be minus 2. Just imagine this line and just rotate 180. Clockwise or counterclockwise is going to be the same because it's 180. If you were to make a rotation of 9 degrees, then this would be plus 90 and this would be a negative 90. This would be a clockwise rotation and a counterclockwise rotation. But to rotate 180 degrees, it is the same, agree? To go counterclockwise or clockwise, it's just this point, minus 3, minus 2. And for this last exercise, it is even easier because this one, it would not hold if I use common sense. That is why I didn't want to do it. This one I had to search at the internet. This one I really didn't know. The others were I just had to just think through. But this one I have to search, and it's very simple. Whatever we make a factor on this image in here, this figure, this polygon, whatever, each of its points, coordinates, we are going to multiply by the same factor. For instance, if the figure it is dilated by a factor f, make f equals 2 or half or 1/3, doesn't matter, a factor f. If we just multiply this image by a factor, if it is 2, we're just making bigger. If the factor is half, we're just shrinking it. If the figure is dilated by a factor f, each point on that figure means this point, this point, this point, D, B, C, or this one in here, it doesn't matter, okay? Each point on that figure will have its coordinates multiplied by the same factor we multiply the entire picture. For example, let's suppose we just multiply ABCD by a factor of 3, where it is going to be our point A. If our point A it is initially at -4, -2, when we multiply by 3, it is going to be -12, -6. And this goes for every point in here. So it's pretty straightforward, right? If the dilation it is a factor of half, we just have to multiply half those coordinates. So this is going to be half of -4, -2. Half of -2, it is -1. Just that. Nothing more complicated than that. We just have to apply the same factor for each point. It's very simple, isn't it? Okay, and that's it. The 3 exercises that I left blank, and now they're solved.